To better understand induction, I think it's important to first distinguish the key differences between induction and conduction. Here we have an example of a conductive type cooktop. Whether it be electric resistance, gas, or halogen, it is important to note that the principle remains the same. We are transferring heat from an element or burner to a cooking vessel. To reach the desired temperature, we must use more energy to counteract our loss in that transfer. The energy loss in that transfer contributes to hotter kitchen environments, and this unused energy equals money wasted. Induction cooking technology operates on an entirely different principle. In front of me, you'll see an exposed induction cooktop. When using induction, the pan itself is the heat source. This is achieved by alternating magnetic fields generated by a copper coil. The molecules within the pan are excited, which in turn produces heat energy. Because the cooking vessel itself is the heat source, we don't have the inefficiencies associated with the heat being transferred from one source to another. Induction units have the ability of real-time temperature feedback. This means that these cooktops can maintain a very accurate set temperature. Another unique feature is pan detection. When no pot or pan is detected, the induction unit is essentially off, not consuming a significant amount of energy or generating heat. When choosing your equipment, pot and pan selection is equally important. To get the most out of your induction cooktop, select stainless steel or cast iron with the Induction Ready logo. Induction cooking technologies have been available for decades, with the first patents dating back to the 1900s. Widely adopted in Europe and Asia, we have seen a growing acceptance and availability here in the US for both residential and commercial cooking applications. This has been supported with the help of many large and well-established manufacturers. If your utility offers 100% clean or renewable energy, then you can have a zero-carbon, climate-friendly kitchen. Now that you have the basics, let's see some of those cooktops in action. Here we can see how the induction unit only interacts with the metal pan. The chocolate inside the pan begins to melt, while the chocolate on the cooktop remains cool and solid. Such precise temperature control means that processes like double boilers used for tempering eggs and chocolate may not be necessary. As you can see, we are still cooking, but there's no burning of the towel.
An induction hob is more like a gas burner than a traditional electric resistance element. The induction hob has quick temperature response, fast heat up, and quick cool down. And you can move the pan for sauté work just like you would with a gas burner. A traditional electric resistance element is slow to heat up, overshoots desired temperature, and remains hot long after cookware is removed. This is a commercial induction cooktop, but your residential induction cooktop will share all of the same performance, health, and safety benefits.